anhydrous sodium acetate, soda lime, heating, water displacement, collection, ignite. That's methane's wildest side. But for precision research and industrial monitoring, we need to capture every subtle fluctuation with absolute accuracy. This is the DFRobot Gravity Laser Methane Quantitative Sensor. Let's simulate the secret behind its power TDLAS technology. A 1654 nanometer laser reacts only to methane. As concentration rises, more energy is absorbed. This spectral fingerprint eliminates interference from water vapor or background gases, ensuring ultra-stable readings. Now, for a performance test. We're connecting both the laser methane and the carbon dioxide sensor to the SCI DAQ module. Why the carbon dioxide sensor? Stay tuned. We'll seal them in a sampling bag and use the same chemical reaction to fill it, ensuring full gas contact. Watch the readings. The resolution is as fine as 0.1% LEL. This precision means even the smallest fluctuations get instant quantitative feedback. Remember the carbon dioxide sensor. Here's the payoff. I'll breathe into the bag. Notice the carbon dioxide spike, while the methane reading only drops due to dilution. This proves its incredible selectivity. Even in mixed gas environments, it stays accurate without false alarms. And unlike traditional sensors, it won't poison or degrade over time. Technically, the DFRobot Gravity Laser Methane Quantitative Sensor covers 3 to 100% LEL, operating from -13 to 58 degrees Celsius and under 80 to 115 kilopascals. With a lifespan exceeding 10 years, it's perfect for greenhouse gas research, bioenergy monitoring, and industrial safety simulations. This is the ultimate high-precision solution. Check out the links below for more info. See you next time. Bye.